Today's focus will be on the basics of graphing. So what are graphs? Graphs are a visual diagram that illustrate relationships between two or more variables that are being studied. So you see the image, you can see the trends. It's not through words, it's through a visual diagram of an image. All right, so there are some basic components of a graph, and you should basically know most of these. First off is the title. So the title is written with it has to be in this order. It is the dependent variable versus the independent variable. And when I say dependent versus independent, you apply it towards the actual graph. Your title should not literally read dependent variable versus independent variable. I have gotten that many times. You literally will look at your graph and put the dependent variable versus your independent variable. We'll be doing an example of this in a little bit. The location, you always put it at the top center of the graph. Okay. Then you've got your dependent variable. The dependent variable is the variable that responds to the change. Okay, so you are changing something, and because you change that, something else changes. That something else is your dependent variable. So, for example, if I tried to increase how often I ran, my mile time would go down. The dependent variable is that my mile time would go down. It is responding to the change of me increasing how often I run. It is located on the y-axis, and the key for this is that you absolutely need to always include your units. All right. Then you've got your independent variable. Your independent variable is the one that you are controlling specifically. So it's what you are directly changing. It is how I can remember is what I for independent am changing. So I am changing how often I run. And I'm hoping that by changing how often I run by increasing it, my mile time will go down. Okay, this is located always on the x-axis. And once again, you need to be including your units. And then the slope is a formula. Okay, first off, its symbol is m when you use it in the equation of y equals mx plus b, that m is your slope. But the formula is your change in y, so you take your two different y values and you subtract them for every change in x. So it's delta y over delta x. That means change is delta, or the triangle. Okay, so let's try to apply what we just learned onto this graph. So a ball is dropped from several distances above the floor, and the height it bounces is then measured in centimeters. Create a title and write the variables on the appropriate axes. So the first thing that I always want to do before I do the titles, I want to do the axes. Okay, so first off, the way that I can remember that the dependent is on the y is you can form a D out of the y axis. See how you can do that? The other way that you can remember it is that it's got the why are you so dependent on me? So you've got the y-axis is dependent. Okay. So what did we directly change? I think it's always easiest to figure out what I directly changed, which would be the independent. And so I am directly changing how the height at I drop it at. Okay, so I'm going to say height dropped. And once again, you need to do your units, so that would be meters. Okay, and so because I dropped it at a certain height, it bounced a certain height. So this would be height bounced. And that would be in centimeters. Okay, so once again, I figured out what I did, and that goes on your x-axis, and then the other one, what changed because I dropped because I did some sort of variable, or I changed the independent variable, the dependent variable will go on the other one. Okay, and so now you got to create a title and write the variables in the appropriate axes. We already did the variables, so now we're going to do the title. We always read left to right in English, same way we do in science, but it is always the dependent variable, which is this guy, versus your independent variable, which is this guy. So I'm going to write height bounce versus height dropped. Okay, it does have to go height bounce versus height dropped in that order. All right, so I'm sure you guys are all very familiar with the equation of y equals mx plus b, and this is for a straight line. So this is only if you have a straight line. What are the different variables? Well, y is whatever your data point on the y-axis is, or the y-axis, yep. M is your slope, x is your x coordinate, and b is your y-intercept. So what the heck is the y-intercept? Well, y-intercept is where the line crosses your y-axis. Which one's your y-axis? This guy is your y-axis. So wherever that line crosses over, this data point right here would be your y-intercept. Okay, its symbol in the equation is b. Most of the time for science, it is going to be 0. It is not always though, so don't force it there, but it typically ends up to be there. All right, so let's try to graph these. First, you're going to have to write down your data points. I'm going to assume that it goes up by ones. So 0, 1, 2, 3, 4, 5. And then I'm going to go up by ones on this side. 2, 3, 4, 5. Okay, so now it says graph and find the slope. So whenever we're doing these data points, first off, this is your x, and then you say your y. Okay, and then this is your x. Oh, that's not showing up. And then this is your x, and this is your y. Okay, so this is x, let's say 2, y2, and this is x1, y1. It really doesn't matter which one you assign as ones or twos, as long as you're consistent with your data points. So I'm going to do my x coordinate, which is 4 and up 3. So this is my first data point. And then I'm going to do 1 and 2. So over 1, up 2. Make sure that you do the x first. And then we're going to find the slope. So we're going to draw a line connecting the dots. So I'm going to get out my straight edge, and which is oh, that's not very good. And you're going to connect the dots. A straight edge is a ruler, by the way. Okay, and so we're going to connect the dots, and then we need to calculate our slope. So what is the slope? We're going to take y2 minus y1. y2 in this case was 2, y1 was 3, and I'm going to divide it by x2, which was 1, minus x1, which is 4. So I'm going to simplify the top. So 2 minus 3 is -1. And I am going to simplify the bottom, which is 1 minus 4. So that's -3. So my slope would be 1 over 3, or 1/3. All right. And then if we look at your y-intercept, well, we didn't make it at 0, 0, right? It doesn't run in it at the y-intercept of 0. And that's okay. Some things actually will start at a different, it won't be forced at 0, 0. All right, a straight line, this is really, really important. This is found on your SAT. This is found on almost every standardized test, is these best fit lines, okay? So what is a best fit line? Well, if you have a straight line, especially in science, what you're going to do is we never connect the dots. You always use a ruler, okay? The point is that you're going to get some random other thing. Like there are other effects that are going when you're taking any science measurements. There are going to be other factors that you're not actually measuring that will take your data point and skew it a little bit one way, and then the next time you do it another way, and the next time you do it another way. And so because of that, what you're trying to do is find the best relationship, and the best relationship is a straight line of an average for most of these relationships that we talk about in the class. Okay, so what you want to do is, after plotting all the points, what you do is you want to visualize the trend and where the line should go. And then you want to draw the line with an equal number of points on both sides. And then you want to get it roughly equal. Okay, so it's as close to connect the dots as possible, but you're only allowed to draw one straight line. So let's try to look at some examples. Okay, so looking at this guy, I've gotten all these different ones. So I've gotten this one's a great best fit line, students say, or this one, or that one. Okay, all of these are lines. That is true, but they're not the best fit. If I look at this guy right here, I have the same amount above as I do below, right? But this guy is so far from the line, and this guy is so far from the line that it's really not considered the best fit. You want as many data points to be as close to the line that you draw as possible. So what I'm going to do is I'm going to get a straight edge, and I'm going to draw from one end to the other with trying to get, that's not even a, trying to get as many in as close as possible. So I draw the line. Okay, it's a little hard on a tablet. That's still not the best. So I would actually want to go a little bit further down. And so that one, once again, it's still not the best. I should be more like in right here, but it seems to be slipping every time I actually. But you have this best fit line. If you notice, compared to this other guy, right, which we had drawn before, these guys on the outside are a lot closer to the line than when we did that first quote unquote best fit line, right? So the dark blue is a better representative of a best fit line. So trying to do the next one on the right, we're going to grab our straight edge and try to do our ruler. And that's not a bad best fit line. Okay, so then we're going to do the one on the bottom left. Grab your ruler, try to get as close. And then this one on the right, it is actually going to be pretty horizontal. It's not exactly, but it's going to be pretty much horizontal. See, it kind of tilts up a little bit on the right. But these are really good examples of best fit lines. Now, the problem when humans do this is that the problem with the humans doing this as opposed to a computer is that you eyeballing it is going to be a little bit different than mine. Now, should your line be close to, let's say on this upper right, this guy? Yes. It should not be like this. That is not a great best fit line. But could yours be a little bit slanted a little bit differently? Absolutely. And so there are discrepancies when you are actually expected to draw the best fit line versus a computer. All right, the next thing that you're going to have to know is these different relationships. And this is talked about in all SAT passages with science, and it's talked about in graphing and everything. It's going to be throughout this entire class. You are going to have to understand the differences between direct relationships, indirect relationships, and inverse relationships. Okay, any direct relationship or indirect is going to be a straight line. The difference is that one has a positive slope and one has a negative slope. Okay. An inverse relationship is that it doesn't do it in a linear format. It does it disproportionately, which means it's more of like a sloped format that constantly changes its slope. So that this would be an inverse relationship. This would be an indirect. An indirect, once again, is just a negative line. And this would be a direct line, whereas one increases, the other increases. Indirect is where one increases. So if I was going along this one, the other one decreases. And inverse is one increases, the other decreases at not the same rate. All right, so this is the visual that I was talking about. So direct, once again, as one increases, the other increased. Indirect would be as one increased, the other decreased. And then inverse is as one increases, the other decreases, but at a disproportional rate, meaning it's constantly changing its slope. Hopefully you understand the basics of graphing, basically the three different types of relationships that we will be discussing, how to calculate slope, and how to label a graph. Have a great day.